Hello everyone, welcome back again to Excellent Solutions, a guide to score 300 plus in Jamb. Today we are going to be discussing physics and the topic is term associated with wave motion. And our today's question are question 6 to question 10. I posted question 1 to 5 in my last video. These questions are brought to you from this book, Excellent Solutions, a guide to score 300 plus in Jamb. This is for physics. All questions are sorted with their answers, topic by topic. Our question 6 here says the figure above, that's this figure, shows two waveforms x and y. If the frequency of x is 30 Hz, so therefore frequency of x is equal to 30 Hz, what is the frequency of y? So if you look at this diagram, this x, as we start from here to here, it makes revolution, number of revolution of x is equal to 1. And if you look at this point, y, here it makes 1 revolution. As it comes here, it makes 2 revolution. As it comes here, it makes 2.5 revolution. So here we now have number of revolution of x is equal to 1. Number of revolution of y is equal to 2.5. So since we have frequency, we have number of revolution. Remember that frequency is equal to number of complete revolution in second. So this is n over y. So therefore, fs is equal to nx over tx. If we make t the subject, we now have tx equal to nx upon fx. So this gives us the number of revolution of x is 1. So we now have 1 over frequency of x is 30, and this gives us 0.33 seconds. So if we come for time of y, the question asks us to find time of y. If you look at this in the diagram, this is when x arrives, and this one is also when y arrives. So both x and y arrive at the same time. Therefore, time of y is equal to time of x, which is equal to 0.33 seconds. So the frequency of y, if we look at this formula, Fy is equal to number of revolution of y over time of y. And number of revolution of y is 2.5 over time of y, we have it to be 0.33. When we divide 2.5 divided by 0.33, we are going to have 75 Hz. So if you look at our options, in option D, we have 75 Hz. The answer is option D. Kindly keep on watching till we solve these questions. The next question is question 7. And question 7 says, a siren having a ring of 200 holes makes 132 revolutions per minute. So number of holes equal to 200 makes 132 revolutions per minute. We can now say our speed is equals to 132 revolutions per minute. A jet of air is directed on the set of holes. Calculate the frequency and wavelength in air of the note produced. Take velocity equals to 350 meters per second. 350 meters per second. So we now come here. The first thing that we need to look is that this speed is given as 132, the number of revolutions per minute. So we convert this one into revolutions per second. So this one we now have S equals to 132 upon 60. And if we divide this upon 60, we are going to have 2.2 revolutions per second. So since this is the case, we can now look at our frequency. So frequency is equal to number of waves per second. So we now have F equals to Ns, which is the same as this 200 times 2.2, and this gives us 440 Hz. So if you now have this as 440 Hz, remember wavelength, lambda equals to V upon F. Our V is 350 divided by our frequency, which is 440, 440. So when we divide 350 by 440, we are going to have 0.795 meters. So we look at our option. Option A, we have 0.795 meters, and the answer here is option A. The next question is question 8, and this question says the distance between two successive crests of a water wave is 0.5 meters. So that is lambda equals to 0.5 meters. If a particle on the surface of the water wave makes two complete vertical oscillations in 1 second, so that means frequency, number of revolutions, is now equals to 2 Hz. Calculate the speed of the wave. We have to find V. So remember that V equals to F lambda. So we now have our frequency, which is 2 times our wavelength 0.5. 2 times 0.5, we now have V is the same as 2 times 0.5 is the same as 1 upon 2. So 1 here, 1, 2 here, 1, 2 here, 1. We now have 1 times 1 equals to 1 meter per second. So if we look at our options, we have option C, 1 meter per second, and the answer here is option C. The next question here is question 9. And question 9 says a vibrator of frequency 60 Hz. We have our F equals to 60 Hz. Is used in generating a transverse stationary wave in a long thin wire. If the average distance between successive nodes of the wave is 45 centimeters, find the speed of transverse wave in the wave. So our wavelength is now equals to 45 centimeters, which is the same as 0.45 meters. So we have to calculate the speed. So we now have V equals to F lambda. We are having 60 times 0.45. When we multiply 60 by 0.45, we are going to have 27 meters. So this is the same as 27 meter per second. So our V equals 27 meters per second. If we look at our options, option A, we have 27 meters per second. The answer here is option A. The next question is question 10. And question 10 says a wave has a frequency of 2 Hz. So we have F equals to 2 Hz. And a wavelength of 30 centimeters. Lambda equals to 30 centimeters. Okay. The velocity of the wave is, so this lambda will now make it into 0.3 meters. So velocity V equals to F lambda, which is equal to our F is 2 multiplied by our lambda 0.3. So if we now multiply 2 times 0, we have 0. This is 6 meters per second. If we look at our options, we have it in option D, 0.6 meters per second. So this solves our questions. So kindly click on the like, share and subscribe button to this channel as I bring you the questions from question 10 to question 15. We have a series of questions here. Subscribe to this channel and you'll be getting daily solutions to your Jamb questions. Thank you for viewing.